it's not often we do this, but we're going to get two radios together. I've probably said before, we have here a Harrier WT1 with a broken aerial and no back. Serviceable battery box, but you know what, it probably even works. And one of our friends, one of our ham radio people, has sent Harvard 410, immaculate, with a back battery door, but unfortunately battery juice has dripped into the phase lock loop area. I've had a go at fixing it. He deemed it was scrap and he can do things himself. But when you look at the board, and we'll zoom in on that, I've tried to do some tracks there. I've actually had it, the VCO locked temporarily on transmit, but there's still no transmits, there's other faults. So yeah, I mean, if this was your only means to get off that desert island in the crash plane, and given unlimited time, you could take a lot of parts out, test them individually and put them back again, but it has no value. So as he suggests, we'll use this as a spare set, and it may even be that the MPSU 32 transistors no good. We have got them in stock, but they're expensive. So put the camera back to where it lives. It has got a telescopic aerial, even though it's on the case, which is somewhere else at the moment. It even came with a carrying case. You don't often see a Harvard carrying case. So we'll open up our Harrier. Just do these contacts with the fiberglass brush, glass fiber pen, scratch pen, and whatever, did I say that right? Whatever other things these can be called. Yeah, I've seen a lot worse than this, but the battery contacts are iffy, there's a good word, to say the least anyway, and were right from the word go on these. So they're not something you want to be leaving batteries in. Now the donor set came with all the screws. And that makes it unusual as well. I'm going to put the soldering iron on ready to see what's going to happen. Oh, these are fun to get into. Don't get your nails cut dead short. I'm so tempted to put a screwdriver in the gap, and with it being my set, yeah, done it. So once you've kind of got that like that, so that it's grinning, you then have to kind of push the top to overcome the plastic clip like that, and then you can just about twist it if you push the antenna through. But you see, once we're inside this set, which you think's never been touched in human history, we actually find it's got a wire pushed in there, extra wire. See, in fact, it has been touched. So it's not as virgin as we first thought. But the aerial's easy to swap because it's in that back section. So we're going to be able to get straight on with the tune-up. And I'll put that naughty one to one side. Very kind of somebody to send that. And he knows where he is at Sheffield. Well, we don't need to address that yet. It's something we'll address later on. So I'll switch the power supply on and we'll set it up for 12 volts. I'm going to put 12.4 volts on the power supply. Remember, these are a 12 volt set, they're not a 13.8 volt set. You can just put 3 1 amp diodes in series to drop it if you want to run it from 13.8 volts. That's what Tandis did for their realistic 1001, 1005 as an adapter. In fact, I'm going to be making, Mr. Chippy's going to make some adapters up and he'll be putting those on eBay. We did some experiments early this month and you can, of course, we found out, power the sets despite it saying charge socket, as long as there's no batteries in it. Oh. Well, that's great, isn't it? So our first problem is the socket's broken. I was hoping we weren't going to have to take the stupid thing apart, but we are. I've never had that happen until a customer's one came in about 6 weeks ago, and it had happened to it because we didn't notice that because we weren't powering it off. Normally we power the radio from the battery contacts there. So then it had to come back and have the socket changed as well, and it's frustrating. Looks like this one's got all the screws. So it looks like it's had some touching up of the solder. Mind you, we're going to have to get to this side to do the synad. And I'll get our little aerial adapter out. That's 3.5mm jack to go in the top there. To like that. Obviously there's going to be a little loss incurred in that, but there you go. I know you can buy adapters as well. But I can't see any ingress of moisture, I can't see any leaking battery juice, so there shouldn't be anything which is insurmountable. So somehow we need to just get the... I'll just start that with a screwdriver. There we go. Not quite sure how they wire that. Anyway, I'll have to go and get a 2.5mm jack socket from stores. So there we are with a new replacement 3.5mm jack socket. Ready to go back in the case. Now then, they have a washer there. Not having a pin driver, but having ordered one 6 weeks ago from the United States and not hearing a dicky bird about it, which is for 3.5mm jacks, still won't help 2.5mm jacks. We're still going to have to faff around like we've done for 30 odd years. tighten it up with the side cutters, which is ridiculous. Right, moment of truth. Plug it in. Way! God, it's noisy volume control. Don't know where the applicator is, but there's a good enough gap to get that in. I'll just switch the power off a moment, then I can waggle the control around somewhat. Hopefully get rid of that noise. I mean, when did this last work? I've probably had it 15 years. Right, power supply back on. Good. Right, we'll put the meter away in the hope we don't need to use it again, and let's hope that's all that's wrong with the radio. So they've crammed something in there which has broken the original, so that can go in the vertical filing cabinet. I'll keep the little screw because you never know when you get a product there where it's missing. Screw, it's a nut. So now we'll connect the radio to the test set with the aerial socket there, just like that. The radio's already on channel, was on channel 20. There we go. So with the test set on the 3 watt range, let's see what happens when we press transmit. Wow, it works. 1.7 watts. That's fantastic. I'm just going to check the frequency. It'll be 27,79125. It was not on the channel or something. Channel out. How can that be? It's not on channel. No, it's not on channel 9. Oh, it's right now. You know what I think it was? I think the channel 9 switch was half depressed. The display was still saying 20, but the radio was actually on channel 9. So the test set's not really been on that long, but I will just adjust this so I'm sure we'll be near enough. As you'd expect a radio this age to have dropped as they do naturally. So we'll just pop that up with the crystal trimmer. We won't use that tool. Of course, a Uniden mic left over from that audio line 341, which had been mega reverse polarity. Stuart's just taken it back to his friend who's the customer, and he'd got a 30 amp fuse in the radio's power lead. So what's he running that off? A car battery? There we go. I'll do. So we'll now start with the alignment of the transmitter. So it's T2, 3, 4 and 5. So we need to eliminate, we have to bypass the loading coil, but using the external antenna socket bypasses that coil, so that's fine. It doesn't tell you that in the manual, but it does. So it's 2, 3, 4 and 5. I don't think this has been played with. I don't think we need to look at it on the spectrum analyzer. 2, 3, 4 and 5. 2, 3, 4, 5. That's where we are. So they're supposed to do 2 watts, I think, aren't they? Let's look at the spec. Yeah, it's supposed to be 2 watts, and the acceptable limit is 1.8. So don't let anybody ever tell you these are 4 watt sets or 3 watt sets. They're not. They're 2 watt sets. And don't let anybody tell you they've managed to screw more power out of it, because the MPSU 31, is it? Output transistor. You don't want to be cooking those. They are hard. They're expensive to come by. I've always had to buy them from the States. They're a Motorola device. So let's have a look at the background music needs turning down in this room. 1.8. So we're already beyond the minimum. We have to use the metal one for that. Go over to that power meter camera. So that's peak. .8 watts. 1.8 watts. That's a bit tight. I'm going to use the metal one. It's 1.8 watts at 12.3 volts. So that's acceptable. It's a 12 volt radio. Does it tell us what the power supply limits are? It tells us what the current consumption should be, and it should be less than 750 milliamps, nominally 650 milliamps. I'm just going to jack the power up very slightly on the power supply just to see when we come in at 2 watts. Bearing in mind we're losing power in my connector. So just drop that, put that up a fraction. So 2 watts would be 13 volts. 13 volts is too high. 12.8 is the maximum I'd want to see, and it is 1.9 watts at 12.8 volts. We'll carry on with the power supply at that voltage, that's fine. And I'm sure from cold, I mean we've had this now running, I'm sure from cold the radios probably do 2 watts. So that's fine. So how are we for deviation? Wallow, 1, 2. I don't know if we're even tuned in. Let's have a look. Wallow. I don't think we are. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. 1, 2. I can't see that. I'll put the oscillator on. Tell you what, we'll use the call tone. I can't see it. I don't know why I can't see it. I'll just put our little Caper monitor receiver on. About time this was charged as well. No, it's not transmitting any audio. Not even from its own internal tone. I think it's just dirty switches. Once again, I'll switch the power supply off. Work that in a bit. Try again. Yeah, it's there now. It's quite low at 0.7 deviation. So I'll take the monitor receiver back off. So it's VR1. It says use the call tone to set the deviation. So VR1 is the one in the middle. So now check that with the mic. Wow, that's too much. Wow, that's not too much. Just check it with the oscillator. Check it with the voice. Wallow, wallow. Yep, that's set. So we've got 2.2 and absolute maximum of 2.5. That's where we want. So why was that adjusted? Can't remember whether we set one's squelch and one's going to be S meter, because they do have an S meter. VR5 is S meter. And VR5 is the bottom one, so that one must be the squelch. Yeah, it is. Right, well that's the transmit done, so we'll move on now to the receiver. Basically it's 7 and 8, which if I oh, not that, is it those two? I just don't see enough of these. Yes, it's those two. Yep. Right. Turn it so the volume's up a bit. Put the signal generator to 2779125. And there we are. So I'll switch the cyanide meter on. We don't do the detector on these, it doesn't quite work like that. And what we now have to do is access the speaker terminal, because there's no extension speaker or earphone socket on this type of radio, which makes them a pain. You have to take the printed circuit board out to do a good job. And in view of the fact that some of this has been fiddled with, that's what we're going to have to do. So it's just a matter, I'm going to put the hot connection just onto the speaker, because it's picking up its negative through the aerial. Okay, so turn the cyanide down for about 4 dB. We'll do those 2 coils. Tell you what, we've got a bit more out of it. They just haven't got the time at the factory to do these as well as they could be. All they have to do is to tune them for a minimum, acceptable minimum, and the conveyor belt moves on. Okay, so let's see what we've got. 12 decibel cyanide. We've got 0.9 microvolts, which is fine. They're a simplistic receiver, they're a bleed over box. It really doesn't matter, it's a walkie-talkie. There's nothing like the use as there were in 1982 when everybody and their dog had a silver rod aerial sticking out of their home and people using these even as base stations. There used to be a lad come on with a terrible hum and he was running one of these with a 300 milliamp unregulated power supply connected, and you can imagine what that was like. I don't know how long the radio lasted. So looking at the specification, what is it supposed to be? Well, they've got it down for 12 decibel, sorry, for 10 decibel. Let's get a 10 decibel reading, just for the video. So move that to 10, and we're getting 0.79 microvolts. So the specification says that they expect it to be 0.5 of a microvolt, but I think that's a bit pie in the sky. The worst acceptable was 1.2. We will well exceed that, well exceed it. So that's great. So we're not going to have to touch that again, so I may as well put the radio back in its case. So I've just turned the power supply off. You don't often see these radios without some pillars broken, especially the one for the meter. So we've put them all in a little bit and then we'll just tighten them up snug. Don't want any strain on anything. And that meter has lined up. So switch the radio back on. We can hear receive. We've got transmit. So it just means, so we're just left with the squelch. And normally you just have to put them on full because it's the weakness in this circuit. And the same circuit's used in the Alba CBM1 mobile. That's the one with the slider controls and the it's on the tip of my tongue. Eurosonic Euro 1 and Euro 2. The call tone becomes a Roger bleep. Obviously it has 4 watts output on that mobile, but it's the same, roughly the same circuit relayed for a mobile, and you've got this same poor squelch. So let's turn the squelch to full. Oh well, the knobs, the whole control's going round in circles, so I'll address that in a moment, but let's see where the squelch is right now. So if I put the attenuator controls on, so at the moment we're at 0.3 of a microvolt and the squelch is on full. 1 microvolt, 3 microvolts, 10 microvolts, it's coming in. Now whether or not I can adjust the preset to make that stronger, so at the moment it's still hanging in at 2 microvolts. Just put that to full. Yeah, you see it's never coming in at that. Well, to be honest, that's one of the better ones. 10 microvolts, coming in at 30 microvolts. Let's see that on a on a finer scale. So, where are we? 15, 20 microvolts. It's coming in about 23 microvolts. So, we'll turn the signal generator back to parking it at 0.3 of a microvolt, put it to standby, turn the squelch down, set it to threshold. There's threshold, switch the signal generator on. So it's coming in at 0.6 of a microvolt and leaving it 0.3 of a microvolt. So yes, it works better than some. So we've just two things to do. Replace that dodgy wire, replace the aerial of course, and tighten up this naughty connector. Might be just easier to pop the knob off that. I haven't actually got any box spanners on here, so we'll just do it with the pliers. The others are alright. I think we'll just clean that top whilst the knobs are like this. It would be sensible. Okay, there we go. So the aerial off the donor set is now installed in this one. Oh yes, I cleaned the knobs. I think we were at the stage where we were going to clean the front. That was right.